All right, welcome to lesson 40. I bet you're just eagerly anticipating this video. Today we're looking at the sum, excuse me, of angle measures of a triangle and angle pairs. And so to understand this lesson, we're really looking at three main concepts. The first concept is understanding how triangles work. And of course, triangles have three angles in them. That's what makes them triangles. And we have this very simple idea that when you take all three angles and you add them together, you get an answer of 180. So if we put this into practice, we could solve for x here then. And so if we look for x, we would want to say, okay, if I add these two together and then subtract them from 180, because that's the total, so 180 minus the combination of those two, I should be able to get an answer. So 105 plus 35 gives me an answer of 40. And from there, then I can say, okay, 180 minus 140 equals 40. And of course, we put the degrees in there. So my 0 is about the same size as my degrees. So let's write my 40 bigger. Boom, 40 degrees. So x equals 40 degrees. Another big thing we're going to look at is the idea of supplementary angles. This, of course, is a review concept too, but for a definition, we want to understand that a supplementary angle is two angles that are side by side that basically their bases form a line. And since they form a line, we know that a line has a measure of 180 degrees. So for example, if I wanted to find the values of x, y, and z, I could work in a number of different directions. I could start with 140 and solve for x first, since I now have this line right here. Okay, that means that 140 plus x equals 180. And so once again, I would be subtracting 140 from, that's a weird looking 4, and x would equal 40 degrees. So now I've solved for x and I have 40 degrees. The other thing then we can see is that really a couple different ideas here. We have the fact that these intersecting lines like this, because 140 and 40, if I'm going to go this direction now, x to y, it's going to be 40 minus, sorry, 180 minus 40, which is going to give me 140 degrees, and then here, like that. And so using this idea of that 180 degree straight line, I can find these supplementary angles. Right? The other thing we start to see is there seems to be a relationship between this angle and this angle, just like there's a relationship between this angle and this angle. Right? 40 degrees, 140, 140. So there is that relationship that you can look for also, but it's all based off on our principle of supplementary angles. The other type of comparison we're going to look at is called complementary angles. Complementary angles, of course, have to deal with adding up to 90 degrees. So once again, our angles have to be adjacent, which means side by side, and together, when added together, they're going to equal 90. And so we see our 90 degree angle right there. And so 65 plus g equals 90, which means we would subtract 65 here to get g. And so 90 minus 65 gives us an answer of 25 degrees. Now, those concepts are all reviewed, so let's put them into practice together, right? We understand a triangle together with some intersecting lines, because this line from here to here intersects the plane from here, not the plane, the line from here to there. And so we have this idea. But from here we can solve all the different parts, right? If I wanted to find A, I know that this angle right here is 90 degrees. This angle is 45. And when I add those together, I get 135. And I can subtract that from 180 because all triangles equal 180 degrees. And so subtract that and I get an answer of 45 degrees. Now from there, I've actually almost solved the rest of this problem, right? Because these two angles, this angle, my 45, and my 90, are actually going to equal angle B, because A plus B equals 180 degrees because they're supplementary. And so if I use the data I already have, right, I want to equal 180 degrees. A equals 45, which means that B must equal 135. If you don't believe me, take 180 and subtract 45. And then, of course, leads us back to C, and we can see a couple different things. We could talk about the corresponding angles here and say, okay, if A is 45, then C must be 45. And we know that because of the supplementary relationship there. And so in the end, our answer would be A equals 45 degrees, B equals 135 degrees, and C equals, once again, 45 degrees. Of course, the lines don't always look so pretty, but the principles still remain, right? And we could talk about what's called alternate interior angles. And that really has a lot to do with these corresponding angles, right? This matching here and here. And so I'm going to leave you with this problem as a challenge problem, as your sample. And I want you to really think hard about this, right? We have a triangle, right? AGV, and we have triangle ATV. And so we have these two triangles. And in the end, right, last hint, right, we start with this shape that really just gets divided in half. And because it gets divided in half, we would say that this triangle is congruent to this triangle. All right, let's see if that's enough clues to get you on your way. If not, be ready to ask questions in class. That's it for lesson 40.